Hello and welcome. In the last video, we had a discussion about how to write ARTL code for a full adder which is implemented using 2x1 multiplexer. Now in this video, we'll try to see how to write the RTL or HDL code for a full subtractor which is implemented using 2x1 multiplexer. So here I'm not going to discuss how to implement full subtractor using 2x1 multiplexer. Already I have discussed in my one video. So I'll put the link of that video in the description. So first watch that video, then this video will be easy for you, will become easy for you to understand. Okay, just to revise the things, the difference equation of the full subtractor is equal to a XOR b XOR c, and summation of m for that is 1 to 4 7, and the borrow expression is a bar b plus a bar c plus bc, and the summation m, the main term expression for borrow for a full subtractor is 1237. We will verify this with the help of a test bench for our RTL. Okay, so this is what a little modification I have did for the diagrams. Okay, so this is what a difference diagram and borrow diagram. I have just connected the selects line of A and B over here, and just I have connected the NOT gates over here for getting the C bar. Okay, and just I have uh, written 1, 2 and 3 for multiplexers to understand the RTL code easily. Okay, this is what a RTL I have written using system Verilog HDL. You can write using Verilog HDL, doesn't matter. The important thing is to understand the logic, understand the concept. If you understand the concept and logic, you can write using any HDL. Okay, so first we'll try to write the logic for difference. So assign statement and ternary operators we have to use over here. Assign difference is equal to this A. Okay, this difference A, we are seeing this A question mark mean 1. If it is 1 in first multiplexer, then we have to see the second multiplexer. In that we have to check the condition. If this B selector line is 1, then C. If this B selector line is 0, then C bar. So if you can see over here, A is equal to 1, then we are checking the condition for B. So if B is 1, then C. If B is equal to 0, then C bar. Okay. Similarly, if A is equal to 0 in first multiplexer, we have to look towards this third multiplexer. Okay. And we have to check the condition for B. If B is equal to 1, then C bar. If B is equal to 0, then C. Okay, so you can see over here same thing I have mapped. If B is equal to 1, then C bar. If B is equal to 0, then C. This is what a simple expression for difference of this full subtract. Now we'll try to see the borrow expression. It is also very simple. Now this is the multiplexer diagram for that. So borrow, this we have to see this select line which is there at fourth multiplexer. If it is 1, then we have to see this fifth multiplexer. In that we have to check the B select line. Okay, if it is 1, then C. You can see if it is 1, B. If it is 1, then C. If it is 0, then 0. This B select line at this fifth multiplexer is 0, then input is equal to 0. So you can see tick 0 1. If A itself is 0, A is equal to 0 at fourth multiplexer, then we have to look towards the sixth multiplexer. Okay, and here we have to check the condition for B. If B is equal to 1, then 1. If B is 0, then C. Okay, so we can see B is equal to 0, then C. This is what a simple mapping for the multiplexers, which is these multiplexer which are actually implementing a full subtractor. Okay, so using assign and ternary operators we have module this. Okay, and whether this design is working as expected, meaning it is generating the proper difference and borrow results as expected, we have to write a simple test bench to verify them. So I have written a system Verilog test bench linear test bench, which is very simple. So for inputs and outputs, I have declared logic over here, and here I am just instantiating our dot here. Dot star is enough in system Verilog. And within initial begin block, I am just generating this stimulus, applying this stimulus to inputs over here. And another initial, I am just printing the values of A, meaning ABC, meaning inputs and outputs, meaning difference in bound, and some simulation time over here. And we will verify whether it is working as expected or not. So this is what here I have written RTL, and here I have written a test bench for that. Okay. So for verifying this design QVerilog file name is rtl.sv, in which I have written the test bench or RTL code. Okay. So it will take some time and it will generate the results. So you can see over here the inputs 000 to 7 111. Okay. And difference is 1 2 4 and 7. Okay, so it is giving as expected. If you see over here, difference is equal to 1 to 4 7 summation of them. Okay, and borrow is equal to 1 2 3 7 as expected. You can see 1 2 3 7. Okay, so we are getting result as expected. After this, if you do the synthesis, if you see the schematic view, you will find the same diagram which we have actually implemented over here. Okay, so after doing a schematic view, you will find the same diagram. So with this, I hope you have understood how to write an HDL code for a full subtractor which is implemented using 2x1 multiplexer. Okay, so I hope you understand the concept, and you enjoyed the video. So thanks for watching this video. Thank you.